Hello and welcome to this video for Transformer Job 1. First we're going to talk about buck and boost connections a little bit more. So a bucking connection is a subtractive connection. In other words, it's going to reduce the amount of available voltage. Typically you'll see that when an even to even or an odd to odd is connected. H1 to X1 or H4 to X4 is an example of that. A boosting connection is when you're making a connection that you will achieve a higher voltage than you originally had. So that's an odd to an even or an even to an odd, as in the examples right here, H1 to X4, H4 to X1. Making either a buck or boost connection creates what's known as an auto transformer. Basically, once you eliminate the isolation from the primary to the secondary coils, you've created an auto transformer, For connection 1, we would have 120 volts applied to H1 and H4, so line 1 to H1, neutral to H4. That would essentially, with the series connection from 2 to 3, that would put 60 and 60 volts on each coil. And with the 10-to-1 ratio transformer, you would see 6 volts on H2 to X2 to X1. And X3 to X4, that's one coil there, so you'd see 6 volts here and 6 volts here. With a meter, you would measure from X1 to X4 and get 6 volts. Or if you connected a load that needed 6 volts, it would go from X1 to X4, and you would connect your load between those 2 points. Next, we have 120 volts again applied to the primary side, H1, H4, giving 60 and 60. Now with a series connection on the secondary side, you would add that voltage up of 6 volts on each coil to be 12 volts usable to a load. Next, we have our first boosting connection. So we're going to put the primary side in series, putting 60 and 60, 120 volts applied at H1 to H4. By boosting that connection, we're going to get up to 132 volts. Okay, where is that extra 12 volts coming from? Well, if we had 6 volts on this coil and 6 volts on this coil, when we put that in series, that's going to add, and we would see between H4 and X1 132 volts. With the next one would be a bucking connection where we would subtract the voltage and get 108 volts. Again, power would be applied to H1 and H4 at 120 volts, and then the secondary would see 60 and 60 by 6 and 6. By putting that in series, you're subtracting that 12 volts. Alright, next we have another version of a boost. The primary here is in parallel, so each coil is experiencing full voltage. We would see 120 volts per coil, which means we would get 12 and 12. By putting that in series, we add that to 24, and we would step up to 144 volts. Alright, next we again apply full voltage to the coils on the primary side. 120 volts and 120 volts would be applied to each coil with power coming into H1 and H4. On the secondary side, we would add that 12 volts and 12 volts from each coil to get 24, but by connecting H4 to X4, we're actually creating a bucking connection, which would subtract the voltage down to 96 volts of usable voltage. Alright, for the rest of the shop job, you can use those examples. Be sure to look at the PowerPoint and include all the drawings from 1 to 8 on your shop job, answer all questions, and you should be able to attempt to finish or figure out the drawings needed for 7 and 8 on your own. Thanks for watching.